Welcome to our 8-6 video. Our lesson essential questions are, can I find the area of a triangle using sine? And can I use the law of sine to solve for missing angles or sides, and the law of cosine to solve for missing angles or sides? There's three things in this chapter or lesson, but they're all plug and chug equations. So let's go into it. So first thing is, this is the area equation for solving if I know the angle. So our normal equation is area equals base times height. And in this case, we have our base is 21, but our height is unknown. So I can actually use this equation, area equals 1/2 a times b, and that's going to be my two sides on either side of the known angle times sine of c. So let's try this one. So I have area equals 1/2 times 8 times 21, those are the two sides of the included angle, times the sine of 68. So just put that in the calculator and we'll get the answer. So when we do that, we get 77.88 units squared as the area. So here's one. You guys try it, and I'll see you when you're done. So I'm going to be solving for area. I'm going to take my included angle and the two sides on either side of it. So I have my equation of 1/2 times 18 times 22 times sine of 32. I put that in the calculator and I get 104.9 centimeters squared. And since we are using area, all these units will need to be squared. So that's the area using sine. Next is the law of sines. So this, as it's the last one, is I don't need a right triangle. So before we have always done right triangle trigonometry with sine, cosine, tangent. Now we're using non-right angles. So what to do with this one? The law of sines is stating that the A, which is the side length across from angle A, is proportional to B, the side length across from B, or C across from side C. So to do this, I would need to know three things. So I might say this. I'll need to know A, B, and capital A, or I'll need to know the two angles and side B. So let's get some numbers here and we'll try it. Let's say B is 10. This is 60 degrees. This is 50 degrees. How do I solve for side A? Well, I'm just going to say, well, that's side A, so that's my unknown, over the sine of 50 would be proportional to 10, which is the side, then across from B over the sine of 60. So if A is up high, we multiply, same type of thing. So this is going to be A equals the sine of 50 times 10 over the sine of 60. And I just put this in the calculator and I'm going to get the right answer. So the sine of 50 times 10 divided by the sine of 60. And that's going to give me the side length of B equals 8.8 units. It doesn't matter if I used B and C, or just whichever side is across is proportional to the angle. It doesn't matter if it's A, B, or C. So here's one for you guys to try. Pause the video and try it. You're solving for angle Q. Welcome back. So I have this set up. I'm solving for angle Q. This side is across from this angle, so I'm going to have the distance over the sine of Q will equal, and I know this as a full pair, so it's 18 over the sine of 51. I want to get Q by itself, so I'm going to need to eventually do inverse sine, but before that, I'm going to cross multiply. So I'm going to get 22 times the sine of 51 equals 18 times the sine of Q. I'm going to divide by 18. So I have 22 over 18 times the sine of 51 equals the sine of Q. How do I undo a sine? I would inverse sine both sides. And yes, I would put a sine, this sine, in that. Remember, sine of 51 or any sine is just a number. So we'll put this in the calculator and get our answer. Okay, so we put that in the calculator and we get 71.8, and since it's the angle, we're going to put down degrees. So this is the law of sines, it's a proportion. Next is the law of cosines. So the law of cosines states that if I know the side, and the angle between it, I can then use that to solve for the opposite side of the angle. So a squared, that would be this one, b squared plus c squared minus 2bc, so that's just the same side from here and here used again, times the cosine of a. This is just the same equation, just in if my reference angle was b or c. So let's put some numbers here and see if we can do some solving. So let's say I want to solve for a squared. Well, I'm going to say this is 60 degrees, this is 10, and this is 8. So a squared unknown equals b squared, that's 10 squared, so 100, plus c squared, 8 squared, it's a 64, minus the 2 times 10 times 8 times the cosine of 60. I can then put all this in the calculator and then take the square root. So 100 plus 64 minus 2 times 10 times 8 times the cosine of 60. All of this equals 4. So if a squared equals 4, I realized that was not correct. In my calculator I hit cosine and it stuck again, so it's cosine of cosine, and that gave me 4. So that's not right. It's actually 84 when I did it right. So then when I square root that, the square root of 84 gives me square root of 84 gives me 9.2, and then whatever units that would be. So that's how I use the law of cosines to solve for an unknown side. So why don't you guys pause the video and you try this one. Welcome back. So this is my equation. I get set up. AB squared is the full length of the side I don't know, equals 4,500 squared plus 6,800 squared minus 2 times the two sides given times the cosine of 122. This number in itself is about 98 million. So I wouldn't probably write that out. I definitely wouldn't round it, but I would put that on the calculator and square root it, and I would get 9,945.9 feet. The law of cosines also has a variation to be used to solve for an unknown angle. So this is if I have all three sides. So if I want to solve for cosine of A, or said unknown side or angle, that would be this one. In the same way, A, so if this is A, this would be side A. And then B and C, it doesn't matter which one's B or which one's C, so I'm just going to put it there. So I'm going to have B as 92 squared plus C, which is 88 squared minus a 25 squared over 2 times 92 times 88. So a, the side across from the angle we're solving for, is always being subtracted. So we're going to take our cosine of a. It equals that. I'm going to inverse cosine both sides. So I'm going to put inverse cosine of all this in the calculator, and I'm going to get the answer. Welcome back. Just with the calculator, you don't want to make sure you put this number here in parentheses, and when you hit division, you want to put those in parentheses. When you get all that in, it's going to come to 15.8, and that would be then degrees for my angle A. So got something here. So with our three rules, we have to determine which one am I going to use. So if I'm solving for sides and angles, I'm going to use law of sines and law of cosines. So take a minute, pause the video, and figure out, not have to solve, but which one of these would you use, law of sines or law of cosines, to solve for A through D. Welcome back. So here I have a pair, an angle across from a known side, and then I have an angle across from an unknown side. So that's going to be a law of sines. Here I have two angles. Each of them is across from a side, but I'm also given this extra side here. So since angle A, which is x here, is the included angle between two known sides, I could actually do both of these. For this one, I have 82 as the included angle between two known sides, so that would be law of cosine. And here I have a known side across from a known angle and a known side across an unknown angle, so that would be law of sine. So take a minute now, pause the video, and do C for, sorry, I meant to say solve for angle X on B using the unknown angle equation. Welcome back. So I'm going to put in the inverse cosine of all of this, putting parentheses around my numerator and denominator, and I'm going to get that angle A put that all in the calculator, and I find that angle A, or X here, is going to be 55.8 degrees. So that is the whole lesson. Sorry, this video was a little long, but there's three things to talk about. So can I find area using sine? Can I use law of sines and law of cosines to find missing sides or angles?